a mathematical treatment for elastic collision. Now, in an elastic collision, the kinetic energy is constant, correct? So here what we have is, we do the same thing, that is, we take the momentum and the kinetic energy. Okay, now when we take the momentum, so we have m1 v1i is equal to m1 v1f plus m2 v2f. Now here the final momentum and the initial momentum, it should be the same, correct? Next, coming to the kinetic energy, here we have m1 v1i square is equal to m1 v1f square plus m2 v2f square. Now you might be thinking, how you got this? Now initial kinetic energy is half mv square, right? So that will be half m1 v1i square, and the final kinetic energy, everywhere you have half, so you can cancel the half, and that's how we got it. Okay, now see, taking these two equations, the above two equations, what we have is m1 v1i into v2f minus v1i is equal to m1 v1f into v2f minus v1f. Now I want you to just look at the equation and then try to understand what exactly is happening. Okay, so if you look at this, again I'll repeat the equation. We have m1 v1i into v2f minus v1i is equal to m1 v1f into v2f minus v1f. Okay, or we can also say v2f into v1i minus v1f is equal to v1i square minus v1f square. Okay, now the RHS part is a square minus b square. So we have v1i minus v1f into v1i plus v1f. Now one of those will get cancelled. So what we got is v2f is equal to v1i plus v1f. So the velocity of the second particle, that will be equal to the velocity of the first particle in the initial phase plus the final phase, or before the collision and after the collision. Okay, now since we got this particular relation, we put this in v1f and v2f and we figure out the formula. So we have v1f is equal to m1 minus m2 by m1 plus m2 into v1i, and v2f will be 2m1 v1i by m1 plus m2. Okay, so we got this, right? Now using this, we have two cases. Okay, we have two cases. Now in case 1, that is if two masses are equal. So if two masses are equal, then v1f will be 0, correct? m1 minus m2, that will become 0, and v2f will be equal to v1i, correct? That means the first mass comes to rest and it pushes off the second mass. Okay, now this is what happens in a perfectly elastic collision. Okay, now coming to the second case, or the case 2. Here, if one mass dominates the other one, that means m2 is greater than m1, like very high. Okay, maybe like you're trying to push a big mountain, something like this. So here what happens, now v1f will almost be equal to minus v1i if you substitute that in the formula, correct? Then v2f will almost be equal to 0, correct? Right, so what exactly happens is, suppose let's say a small rock, okay, a small rock, let's say you throw that small rock to a wall. Now what happens, the rock will rebound, correct? Or if not a rock, take an example of a small ball itself, which we usually do. So when you throw a ball to a wall, then what happens? The ball will rebound with the same velocity, whereas the ball will not at all move, correct? So the heavier mass is undisturbed while the lighter mass reverses its velocity. Okay, so this is what happens in an elastic collision. So go through the video again and understand how the derivation is.